Bonjour, je suis ravie de vous voir ici. C'est mon deuxième fois à Devox France. Aujourd'hui, je parlerai anglais, désolé, mais si vous voulez, nous pouvons discuter sur ce sujet en français après. Okay, for those who didn't understand, don't go to Devox France if you don't speak French. I just said that I'm gonna speak English, but if you wanna speak French afterward, we can do it after the talk. So today I'm going to talk about how to have a healthy diet for your Java application or how to make your application eat memory healthy. First of all, let me introduce myself. My name is Marharyta. I am a software engineer at Sonar. I do some conferencing. I often speak at some famous conferences, and I used to organize them in my native cities, organize the JAG at Kotlin user group, and I am a huge fan of different programming languages like Java, Kotlin, Scala, and I am writing static code analysis as my everyday job for them. And this is my Twitter handle, so you can follow me if you want to listen some technical stuff or some stuff about life. There is also one more important thing you should know about me. I'm Ukrainian. I was born and raised in Kyiv, and only for almost 4 years I live in Switzerland. And today my country is in danger. We have problems with our nearest neighbors, and we need all the support that people can do it. So first of all, please don't forget about Ukraine. And the second, if you haven't spent all your money on tickets for Devox France and you still have something left, I'll encourage you to make some donation to help Ukrainians fight for our freedom. So the most important part of my talk is done. Now we can have some fun. So short disclaimer. The things that I'm going to tell you today, they're not rocket science. Like, you probably heard them, read them, it's written in all the books. Sometimes maybe you're missing some structurized knowledge, you don't know where to look, which tools to use. So I would rather help you to structurize it, but I won't tell you anything new. You probably already know everything. And another disclaimer that there is no single silver bullet. So every time you face a problem with your memory usage, you face memory leak, you have to debug it, you have to understand it, you have to look into the code and fix it in the way how it's supposed to fix. So it requires some understanding of your code base, and I cannot give you the exact recipe, but I can give you some hints. So, how it all started? Why am I here talking to you about the memory leaks? Some time ago, there is a guy called Alexei Shepelov. He is principal engineer at Amazon, and he is also famous for his contributions in OpenJDK and projects like GMH, GCStress, and Java Object Layout. And one day he came to us and said that he wants to analyze JDK in Sonar Cloud. And this is super cool because I'm doing the tools that help Java to be better. And he came to us and said, I want to do it using 3 gigs of RAM. And it was okay, that sounds a little bit tricky. And of course he cannot. He failed miserably with OutOfMemory, and he asked for help. And why it's important for us? If you actually, raise your hands if you're using SonarQube or Sonar Cloud. Don't be ashamed. A lot of people, if you don't do it, you can, because it's great tools that we are working on, and we try to make the world better, so don't hesitate to try them out. So, usually when you use SonarQube and Sonar Cloud, it goes to your CI. There are cases when it does not, but usually we are using your CI, and it means that you don't only pay for the tool, you also pay for the analysis to your cloud providers like AWS, Azure, Google Cloud, or whatever. So the more analysis is taken, the memory, the time, the more you pay. And because we care about our customers, we want you to pay less on the infrastructure, and that's why this is important to utilize the resources in an efficient way. And this another case, it could be SonarLint that is running in your IDE, and usually this is your local machine. And of course, it's important for us to take less memory and be more efficient on your local machines. So, and at the same time, I got back from my maternity leave and I gave birth, and I wanted to come back in shape because it's not a secret that usually women after giving birth gain some weight and are not in the best condition. So I was trying to do it, and everything mixed up in my head. And I was thinking at some point that I'm making my application fit too when discovering and analyzing these memory leaks. So I found a lot of similarities in the way how we treat our applications and how we treat our bodies. So I had this idea that basically we can treat our applications as our bodies and find a lot of analogies to explain memory leaks to people. So this is how I get the idea of the talk, and I come up with an algorithm, the same algorithm that I had for myself when I tried to get back in shape. So the first step was to ask yourself a question: is there any problem? It's important both when you try to get back in shape, and this is important when you try to analyze your memory. Do you have any problem? If you're satisfied with your appearance, if you're okay, just don't do it, don't waste your time. Try to do something else, something more important. The same for your application. If you're satisfied with how much you pay for your cloud providers, if you're satisfied with how your application's performance, spend more on deploying new features, on scaling, doing something else, if you're satisfied. So first of all, you need to understand if there is any problem. But how could I know if I don't know, am I satisfied or no? Why? Why don't we know? Why it's so hard for Java developers to understand whether there is any problem with memory? Because back in times when I switched from C++ to Java, I was so happy to have garbage collector, and I thought I should not care about memory anymore. Now garbage collector can do all the magic. But unfortunately, that's not always the truth. Why? Garbage collector is great, is helping us a lot, but he's not the wizard. Garbage collector cannot collect objects that they are still referenced. And this is your responsibility, the developer's responsibility, to not reference the things that you don't need. And And how can we know? There are some symptoms that can help you to understand there could be some problem with your memory. The same as with your body. For example, you see that your clothes became too small, your fat percentage became too high, and it's difficult for you to run, walk, breathe, and BMI is too high, and so on and so on. And the same for your application. Out-of-memory error, it doesn't mean that it has memory leak, but it can be one of the symptoms that you can pay attention to. You give more memory after you have out-of-memory error, but it doesn't help. The more memory you give, everything is eaten by your application. It could also signal you about the problem. Your application spends much time on garbage collection because it cannot collect, but it tries. There are long GC pods, and it affects your performance. It affects your spending too much time on CPU, and so on. So this could be the symptoms that allows you to pay attention to the memory war and tells you that you need to see and to check whether there is any leak or no. So, okay, I see the symptoms, but how do I know whether these symptoms are really bad or maybe it's just the feeling? Let's measure. Numbers never lie. So if you don't know how to, whether there is a problem or no, we need to measure. For the body, it's pretty easy. There are a lot of things that you can measure. First of all, weight, fat, muscles percentage, BMI, heart rate, do blood tests. And the more things you can test about your body, the better, because the better picture you'll have. The same for your application. You can look at the memory usage, you can use the performance, like time spent, CPU usage, you can generate heap dumps. It's actually one of the most important things. Look at the logs, and so on and so on. So you need to collect data and measure and use some tools to measure this data to understand how big is the problem. There is one important thing that you should know. Just one measure might not be enough. For example, in your body, if you just have a higher weight, it doesn't mean that you have a problem. It could be anything else. It could be water, it could be stress, it could be just different phase, or you just ate something, and that's fine. For example, if you look at this graph, do you think there is a memory leak? Actually, I don't know whether there is any memory leak, because it's just the graph. It could be a normal application memory usage. But what could help? Looking at GC activity or CPU usage could help you to understand whether there is problem or no, because here you see that CPU was utilized there was pretty big amount of CPU utilized. So GC tried to do some stuff, but he could not. So this, together with these two graphs, that can signal about memory leak. But still, it doesn't mean that there is a memory leak. It just gives you some symptoms that you need to investigate. Okay, so Alexei, of course, he knows that this is not easy to investigate memory leaks, and he tried to help us. He provided heap dumps, logs, memory analysis, and whatever he could give to us, so help us investigate. And when I was looking in the logs, I found out this stack trace. I was looking at the stack trace, and I realized that this is Sonar, CPP, blah, 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 something, and this is awesome. Why this is awesome? Because I'm in the Java team. It means that this stack trace is coming from C++ analyzer. So it's not us. What we could do, we just take all the things that we have, pack it in them into the box, and send to my colleagues from C++ team so they can investigate the issue and we are free. Do you think that's right? Yeah, of course, that's how we should work. And now I need to reveal you one secret. So please, if you don't want to hear the secret, shut your ears, because after this secret, your life won't be the same. It will change your life forever. Are you ready? So if you have a stack trace of the out-of-memory error, the best thing that you can do with it is to take it carefully and throw it away. Because when you have out-of-memory, stack trace is close to useless. Why? Because out-of-memory happens when you ran out of memory, but it doesn't show you where the problem is. The problem could have happened somewhere else. Something else could have eaten lots of memory, and then there is just a normal function that tries to operate, but it could not because there is not enough memory. And that's actually what happened. The out-of-memory appeared in C++, but that was not the root cause of the memory leak. So we should not just blindly give it to the other team. We have to investigate it deeper. So that's the sad secret. Sorry for that. Okay, we learned how we can measure, what we can use to measure. Now let's analyze. So the best thing that we can analyze is the heap dump. I already prepared some heap dumps for you. As an example, let's look at them. Are you familiar with this UI? Have you ever seen it? This is Visual VM, the most basic tool that is provided with Java that you can analyze Java processes and their heap. And this is the heap dump. So as I told you, logs, stack traces are almost useless. Heap dumps are very important when you are analyzing memory leaks. So honestly, when I first see this UI, I don't know where to look. A lot of numbers, a lot of classes, instances, so on, but I don't understand where should I go. And what actually the strategy I'm trying to look, I try to find something that draws my attention, that is abnormal. For example, here we can see that 97% of the memory is in byte arrays, which could be okay, but sounds suspicious. Let's look there. So we can look there. And what nice thing that this tool can provide is this GC root. GC root shows you the root from this object to the GC root. So to explain you why this is still referenced, who is referencing it. So you can see that this byte array is referenced in some static names cache here. And if we look there, second, third, fourth, and all these elements, they have the same static names cache in names cache example here class. So probably there is something fishy there. Let's look into the code. And of course, what we can see static field here. So now I have a question for you. When static fields are eligible for garbage collection? Who thinks it's A? Raise your hands. who thinks it's B? Come on, guys, are you still sleeping? So, okay, I won't waste your time much. The honest answer would be B and D and, okay, C, but C is like too far away. That's not what we want. Why? And because, like, let's see in the diagram how it actually works. Usually when you program, you deal with instances. Every instance has reference to the class of which instance it is. Then every class has a reference to its static fields. So static fields are in class. And then the most interesting part. Every class knows about the class loader that loaded this class. And every class loader knows about all the classes that this class loader loaded. Which tells us that when we want to get rid of static field, there should be no reference to it, or there should be no class. And if we want there to be no class, it means that there are no instances and there is no class loader. And when class loader is garbage collected, so actually if it's not your custom class loader, but the system one, it's never or when JVM exits. So technically, if you don't do your custom class loaders, don't write your custom class loaders, your static fields are there forever. And if you have some leak there, if you put some garbage there, they will be occupying the memory for a very long time. So that means that static fields are eligible for garbage collector when class instances collected, when class loader is collected, and when there is no reference on it. And technically, almost never if you don't use custom class loaders. This is a little bit sad because one of the leaks that we found in Java Analyzer was with static fields, that we put something into static, and it was never cleaned up. And that's why statics are like sugar. Static members live almost forever. Static members should be avoided. Probably you read it some books like Effective Java and about that you should avoid static members and only use static constants or class members or instance members. Then static members, if you still need them, they should not be mutable. Because if they're mutable and if they're like collections, they can grow very fast. And even if you need them to be mutable for some stupid reason, please don't make them updatable from non-static methods. So these are the things that we can control, like following these best practices with statics. And in Sonar, we have some rules to actually monitor if you violate some of these principles. One rule is that mutable fields should not be public static. And another rule is that you should not write from instance methods, should not write to static fields. Of course, that won't eliminate all the problems with static, but at least will give you some safeguard. Okay, we learned how to analyze, but in this case, it was pretty easy to find the root cause. Sometimes it's not that easy, so let's look at the different example. And this example is also taken from the real life. So again, we see the similar situation, 97% here. Let's look. GC routes. And what we can see. We can see that this byte array is referenced somewhere in the table in some linked hash map, in some hash map. This one is the same hash map, the same hash map, the same hash map. So looks like there is something fishy in the hash map. This is coming from the class example controller, so let's look there. So this is the names cache. This is a hash map, okay, probably the one that we are searching for. It's not static, so there is no problem there, but let's look at how we are actually working with this. If you look attentively in the code, you can see that this name, it's a string, and it could be either A or B. There is no third option, A or B. Then we create the full name out of it. It could be full name of A or full name of B. And then we put into the hash map this full name So technically, if full name is a key, and it could only be a full name of A or full name of B, there should only be 2 instances in this hash map. But that's not what we see in the heap dump. Do you have any idea where the problem could be? Okay, was pretty easy for you, okay? Not that always that easy, but yeah, indeed. Let's look at the equals and hash code. So we see there is equals and there is a hash code. And what hash code does? Hash code does random number. So why this is so bad and why do we have leak here? Because if you know how hash map works, firstly, you need to calculate a hash code. And based on the hash code, you need to understand in which bucket you go, and whether if the instance already exists, you use equals, you just rewrite it, and if no, you go in the same bucket, but further. What happens if hash code is random? If hash code is random, it means that you might not find the proper bucket, and you will never get the proper object, and it means that you will be putting into the hash map objects more and more, but you will never overwrite the same object. So it means that instead of having 2 instances, we might have thousands of instances. So let's go back to our presentation and see that, okay, equals hash code are like carbs. We need them. That's the most crucial part, and all the hash maps and the algorithms work on this, but we need to understand and properly remember how to use them. And even, honestly, I've seen a lot of problems in the code from people who know this contract, but sometimes they forget, and sometimes you don't think that you're using something in the hash map, but you're actually using it into the hash map. So, first of all, we should use them properly. When we override equals, we should always override hash code, no matter what. Even if you think that you'll never use this class as a key in the hash map, always override hash code. And there is a contract. If equals for 2 objects returns true, their hash codes must be the same. And this contract is there for a reason. So in Sonar, and hash map keys must be immutable, because if they're immutable, you can change them, and you have the similar problem as with the random hash code. So, in Sonar, we have some rules to help you avoid the problems like this. For example, equals and hash code should be written in pairs, but sometimes it's actually pretty difficult with static analysis to test whether you don't violate the contract or not, so we don't have the rule, but there is a tool that I can recommend for you to check if you have obeyed the contract with equals and hash code. It's called equals verifier, and you just write one unit test, it's one-liner, but then you are safe and you can see that you don't violate this equals and hash code contract. So here are the links. I'll share slides afterwards. So this is the tool worth looking into. Then, okay, we found the root cause. Sometimes it's easy to fix, sometimes it's not. So let's maybe learn something, look at more examples. So again, my favorite visual VM. So I'm looking here, and honestly, this time, I don't understand where should I look, because you see there is 52%, it could be okay. I can probably look here again, but it's not 97. Come on. So sometimes it's pretty hard to understand what's going on looking at Visual VM. Sometimes Visual VM is not really nice to you. And for example, if you look here, it goes to some static files, zip, hash map table, and I honestly don't see any reference to the code that I wrote here, so I cannot investigate. What can I do next? There are other tools that can help you. For example, in my case, I really like Eclipse Memory Analyzer. This is a free tool that you can use to actually, that can help you to investigate the issues. So I asked Eclipse Memory Analyzer to analyze the same heap dump, and it showed me some suspects. So it tells me that the suspect is somewhere here, because we have a lot of objects of the type big object, dollar small object, big dollar object, dollar small object, and so on. So there are a lot of things like this, and probably there is something fishy, so we can have a look at the example controller 3. Let's have a look there. Okay. So, first of all, what we can see? We can see that almost on every get call here, we create small object and put it somewhere. But this is small objects. They should not they seem to be small. But how do we create them? We create them with a big object, new small object. Why do we do this? Because actually small object is inside big object. And you see my IDE is yelling at me. Why? Because class small object is non-static class inside big object, which means that it actually has a reference to the instance of big object. And while you think that because you just called constructor here, big object will be garbage collected, it won't be garbage collected because the small object here keeps reference on big object, and we have the small objects, and we put them somewhere in the list. And we can see that big object is having 1 million strings there, and they're all in your memory. So the problem here that just by forgetting static here, we created a huge memory leak that even Visual VM could not help me to investigate. So what's the point? Let's go back to our slides, sorry. Inner classes. Inner classes could be also the cause of memory leaks, and what should we do with them? First of all, try to use static inner classes. There are very few cases when you don't need static, when you need non-static inner classes. If you still need them for some reason, take care of the like cycle and see that how the when outer class should be garbage collected. And you need to think about the outer class as well. And we have some rules about this in Sonar, of course, that inner classes which do not reference their own inner classes should be static. But unfortunately, we don't have a rule because we cannot enforce all inner classes to be static. So this is up to you, up to developer to design your code properly and try to avoid using non-static inner classes. And I think there is one more demo that I wanted to show you. Hope we still have some time. Yeah. So this is again the fourth example. Let's go our standard path. It just in my cases I used string for examples, but it's not always byte array. So that's just artificial examples. So we can look at GC root, and we can see this is one pretty straightforward. We can see that this is referenced in thread local. This one is also referenced in thread local, blah, 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 thread local. So now we found the fourth possible problem that could lead to a memory leak. These are thread locals. And because thread locals live as long as a thread is alive. So if you created a thread, run it, and then it's disappeared, that's perfect. But if you're using some execution service or thread pools, like the things that people are usually doing, it means that you have to manually set and unset thread locals, because otherwise they will be there. And if they occupy much memory, this memory will be occupied for a long time. We have a rule for this to not forget to unset thread locals. And come on, it's Java 21, Project Loom is coming, virtual threads. Probably there are better ways than thread locals. So, okay, we found some probable use root causes of the memory leaks. They are not all. Of course, there are much more possible root causes. Just some examples to show you how some stupid mistake can lead to a huge problem. But okay, we found all of them, we fixed them, and we can stop here. But it wouldn't be me if we should stop here. Let's go further and let's try to improve. What can we improve? Let's go the extra mile. And here I would like to talk with you about memory leaks versus memory footprint. Previously, we've been only talking about memory leaks. And memory leak, in simple words, is a situation that is like bad, that you have to fix. It's like if in terms of your health, it's when you're very heavy, overweight, you cannot leave your apartment, like you need to fix it immediately because of medical reasons, because it's it threat to your life. Memory footprint is a different thing. Memory footprint refers to the amount of memory that your program occupies, and reducing memory footprint is a different thing. It's usually when you're already in a good shape, but you just want to have a little bit more muscles, a little bit less fat, you want to, I don't know, be more athletic. This is about reducing memory footprint. This is when you're already good enough, but you want to like be better on the memory side. This is more about not just health issues, but just like your personal will to go extra mile. So how can we reduce memory footprint? We can actually remove all the references manually. That's what my colleagues from C++ are doing. I don't want to go that direction, but it helps. Another point, you can write custom class loaders, and we looked at static fields in order to garbage collect them. We can write custom class loaders, and it will help, but it comes with a price that you have to maintain custom class loader, and if you need some classes again, you have to load, unload, and that might not worth it. But this is an example how you can write custom class loader. You see that here you maintain the reference to it, and once it's garbage collected, all your statics are garbage collected. Another point is to minimize the living scope. Like, keep the mindset that your object should be as short-living as possible. Prefer something local rather than something static, something global. And this will help garbage collector to reduce your memory footprint. And do all the necessary cleanup. If you had to leave something, if you had to have some cache or some other stuff, don't forget to clean this up when you don't need it. And another interesting thing, we can use weak reference. Are you familiar, guys, with weak references, or should I explain? So, okay, usually the references that we are operating with are strong references. It means that if garbage collector sees it, it doesn't touch the object. But if the only reference that is left is weak reference, garbage collector can decide to garbage collect the object, and if it needs more memory. And this way, you will free up more memory, but you always need to have the algorithm or a way to recreate the object again. So it comes with the price of recreating object, but it frees the memory if the memory is needed. And this is an example how we could use big object in one of our small demos. But we should understand that we cannot reduce memory footprint forever because it comes with a price. For example, when I was trying to get back in shape and I lost too much of my weight, it was difficult for me to actually exercise, to carry my child, because the weight was really low for me and I had to gain a little bit more weight to be able to exercise, to be able to operate properly. So you cannot lose too much. And there are some performance costs, because if you have custom class loaders and you have to load and load, if you have weak references, you have to recreate, and it takes from your performance. So this is like the balance is the key. You need to understand what works for you, for your application, what is more important for your application, and only you can answer these questions. So we improved, we reduced the memory footprint, and what is the next step? And the next step is like to never make it happen again. Let's try to prevent potential memory leaks, at least in the places that we think are dangerous. And in order to continue with that topic, let's recall, do you remember how it all started? It was Alexei Shipilov who wanted to analyze GDK in Sonar Cloud, 3 gigs of RAM. So what was the problem? I want to show you the heap dump because it's too huge, but in simplified version of the problem looks like this. We have plugins, a lot of plugins, but in our case, the more important are Java and C++ plugin. They were both in one collection. And these plugins were executed in for loop. That means that only when all the plugins are executed, only then they are garbage collected. So what happened? Java plugin had a few memory leaks in different places, and it left a lot of garbage in the memory. Then C++ plugin tries to do something, but because Java ate like 80% of the memory, C++ plugin could not do anything, and it failed with out of memory. And it would be unfair to blame C++, the plugin developers, and not blame Java developers, Java plugin developers. So that was the problem. How could we avoid this kind of problem? First of all, maybe Java plugin should go last. Like, we know this is a shitty plugin that always eats a lot of memory. Let's just make it last, so at least all other plugins can go and live. Could be the solution, not the one I prefer, but yeah. Maybe we can have some cleanup between plugins, like destroy it manually. Would make sense. Another possible solution could be to reduce the life cycle of the plugin. For example, instead of using the list, we could use a queue and do queue pop, and maybe that could help. So, for example, it could look like this. You see that this way we won't have memory leak, because whatever garbage Java plugin left, it will be destroyed once Java plugin is done. But what's interesting, if we put these things in place, we would have never noticed that we have a memory leak there, and we would have never potentially fixed it. So sometimes things like this can actually hide the real problems. So that's just food for thought. I don't know how to keep this, what is the best way to solve this problem, but just keep in mind that putting some preventions may hide some problems. So, how to prevent memory leaks in general? First of all, follow a healthy diet, as I, for example, proposed you in this talk, and you can read a lot of books, articles, and there are a lot of people talking about this. So these guidelines are not are for a reason there, and there is a reason why you should not use statics, thread locals, and be careful, and so on. Then monitor memory usage from time to time. Look at GC logs, perform stress testing. This is important especially for web applications to see how it behaves under a huge load. Use tools like Visual VM, Memory Analyzer. These are free tools. There are also paid ones, like, for example, Flight Recorder and so on. There are many on the market. You can choose what suits you best, but you probably need to use one to keep control of your memory usage. And another simple thing that we all can actually do, we can add some tests, like unit tests. There is a project, Java Object Layout, which I like, and this is using Unsafe, can help you to identify how much memory is occupied by exactly this object. So using this, you can write tests. For example, we remember that there was a huge problem with big object, small object there. And we remember that this is the maximum amount of memory it should occupy. And if at some point it starts occupying more, you can write this assertion, and it will fail. It doesn't mean that if the memory goes higher, that there is a problem. But at least it will signal your developers that please pay attention, there was a problem there. Maybe you can you can review what you've done. Maybe you introduced another leak. Of course, you cannot put tests like this everywhere, and it's not like a silver bullet, but at least it can help you to prevent the places where you knew the memory leaks were before. So this is sort of a summary of healthy diet: avoid statics and immutability, clean thread locals, free resources, avoid non-static inner classes, and so on. So all the things that we discussed today in this presentation. And of course, I've been telling you a lot about that story, but are you interested in how the story actually ended? So raise your hands if you think that we fixed memory leaks. Well, few people. But I remember I made like similar question in long time ago in my talk at Australia, and there were 3 cities, Sydney, Brisbane, and Melbourne, and nobody was raising their hand, like nobody was believing in my team. Here, like, I don't know, around 20% of the people believe in my team, but okay. Thanks at least for that. And who thinks that we haven't actually fixed these memory leaks and they're still there? Okay, what else? What other people are doing, I don't know. Probably they're still sleeping because it's early. Sorry, it was not my decision to put this talk that early. So, how the story ended. So Alexei wrote a Twitter post that 2 months ago he moved Sonar Cloud scanners to a smaller VM, and he got memory out of memory, and he reported it and get confirmation that there is indeed a leak. Then deployed the new version of the plugin, then a new version of Sonar Cloud, and from not being able to analyze it with 3 gigs of RAM, we are now able to analyze it with 1.2 gigs at max. It deserves some applause. It was a huge work. It's analyzing OpenJDK, so like not really small project. And we sent to Alexei this nice T-shirt. So it means that if you find something fishy in our product, if you report us some problems, we listen to you. And if your contribution is really valuable, you can get this T-shirt as well. So maybe we'll encourage you to give us some feedback more. So the story ended happily. Here are some useful links that I'll leave here that you can see that I used to prepare my talk, and some useful tools that you can use, and some kudos. First of all, kudos to my colleague who helped me to analyze these memory leaks and gave me some hints and helped me to prepare this talk. And thanks a lot to my GVM squad who actually made all the job, fixed the memory leaks, and made our Java analyzer even greater. So, and of course, thank you for listening to me. And I'm really happy that I have so many people, even if this talk was not in French. So next time I'll try to do something in French. Thanks a lot for your attention. And we have, I think, 2 minutes left if you have any questions. I have also Swiss chocolate, so for the best question, I can give it.
Thank you for this presentation. And I have a question about how to analyze memory. What are the best tools to analyze memory from a day-to-day basis instead of only when there are errors? Are there a recommendation to use tools and extracting heap dump regularly and things like that instead of only when issues happen?
Yeah, I see. I understand this question, and I think that's the problem that we all face once we face this memory leak, like how to prevent it. There are tools that can help you monitor like this from time to time, like use at least visual VM, or you can use a flight recorder or more advanced tools that actually integrate in your production environment and help you to monitor. One of the things that can help when I worked at web applications was performance stress testing. So unfortunately, like from my experience, there is no like safety net that will forever prevent you from having memory leaks. But at least having some tools will help you to look there from time to time. What also helped us that we generate sometimes heap dumps in our like some of the builds of our analyzer and our some analysis that we run in our dogfooding. It helps looking into heap dumps from time to time. But yes, once you fix some memory leak, usually you'll go back into that subject once you have a next memory leak. So I don't know how to make this sort of part of the process, but probably like if you make it part of the process, part of the validation, it could help.
Thank you.